Hey guys, hopefully you are already done with your warm-up. You've kind of got your foldable filled out and you're good to go. Okay, I'm going to just review it to make sure that you're good with coordinate graphing. It should be a review of something you already know. On the front, we haven't labeled that yet. What I want you to do is label the different quadrants of the coordinate grid. Some people have a hard time remembering the order. What I like to do is draw a C for coordinate grid, and that gives me the order for my quadrants. So I started my C up in the top right hand corner with quadrant 1, and it just follows that C around to quadrant 2, quadrant 3, and quadrant 4. Okay. Within that, I want you to make sure that you remember how the quadrants work. So if you start at the origin, you start at the center, when you're plotting a point in the first quadrant, you would go to the right, which is positive direction, and up, which is positive direction again. So your X and your Y coordinate are both positive. In quadrant 2, when I go to the left, I've got a negative X, and then I go up for a positive Y. In quadrant 3, I go to the left, which is negative, and down, which is negative. So that's a negative X and a negative Y. In quadrant 4, I'm to the right, which is positive, and down, which is negative. Okay. And I know I'm going quickly because this should be a review of what you already know. Okay. Some people have a hard time remembering which one comes first. One way that you can remember is X comes before Y in the alphabet. So you can always do your X before you do your Y. Another way some people remember is that on the coordinate you would run before you jump, or you walk into an elevator before you go up and down on the floors. Okay? Whatever works for you doesn't matter to me. All right, on the inside, you should have been taking some notes already, so we're going to go through those pretty quickly. Hopefully you have already started working on the extra credit, so you've already been graphing some points, and this should be absolutely no problem. So I'm going to go over these first two kind of together. Point A is at 9, 4, so that's a positive 9, so right 9 and up 4. Point A, and that point A is in quadrant 1. Because the second part says to label the quadrant or axis for the point. Okay. Point B is negative 6.5, so I'm going to the left 6.5, and then up 4.5. 4.5 for point B, and point B is in quadrant 2. Point C is at 2, positive 2, negative 5 3/4, so down to negative 5 3/4, excuse me, and that is in quadrant 4. Point D, negative 7.5 and negative 7, and that's in quadrant 3. Point E is at 0, so it doesn't go left or right, but it does go up 7.5. Okay, and that's not in one of the 4 quadrants, but it's actually on the y-axis. Point F, negative 10, so to the left 10, and then 0, so it doesn't go up or down anywhere. So again, not in a quadrant, but actually on the x-axis. Point G is at 4, 6 2/3. Okay. So that is in quadrant 1. And point H is at 12, so to the right 12, and then negative 6, so down 6. 12, negative 6. And that is in quadrant 4 again. Okay, that should have been a quick review. Just like this next box down the bottom left is going to be a quick review as well. We are naming where the points are, giving their coordinates. So point J goes to the left 9, so negative 9, and then down 1. So J is at negative 9, negative 1. Point K is to the right 10, positive 10, and then down 4. So 10, negative 4. Point L is to the left negative 4 and up 7. Point M is 0 because it doesn't go anywhere left or right, but then negative 7. Point N is to the left 3, negative 3, up 8, negative 3, 8. And finally, point O is to the right 8, but then it doesn't go up or down, so 8, 0. Now, I expect that all of that should have been a quick, easy review. This last one is probably the only one where I think you may have had some trouble. So I'm going to pull out some different colors to help us out with that one. The first one says, which points has an x that is greater than 2? So a couple of ways that you can do this. You can look at the x values of some different points, okay, and see one that's greater than 2. So negative 9, that's less than 2. 10, that's greater than 2. If I look at k, that's one that's going to be greater than 2. Okay. Another way you can do that is by drawing a line. X greater than 2. So here's our x, okay, and here's 2. I'm going to draw a line at the 2. Okay. And if I want greater than 2, that means I want everything that's bigger than 2. So everything to the right. You can draw that line if you want. You do not have to. So x greater than 2, I'm going to find anything that's to the right of 2. I don't want what's on the line because it doesn't say greater than or equal to. It just says greater than. So those points would be G, O, A, K, and H. Okay. So you can go through and check each one and find which ones are greater than 2. Okay. So point O, yep. You can go through all of those, or you can just draw the line and figure out which ones are to the right of it. Okay. Our next one says, let's see, what is the next one? Which point has a y that is less than negative 3? So here's my y-axis. I want less than negative 3. So here's where y is negative 3. I'm going to draw a line. Again, you can draw the line if you want to. You do not have to. Okay, if I want it to be less than negative 3, that means I want everything that's under negative 3. Okay. Again, if you want to, you can check your y values this way. Look at which ones are less than negative 3. Or you can draw a line and I can get everything that's underneath it. So that's D, M, C, K, and H. All right, our next one, the next one that we are given, we want where y is less than or equal to negative 4. So I'm going to start with my y, negative 4. So I'm going to draw a line. Okay, it says less than or equal to. So can I include k since it's on the line? Yes, I can, because that's equal to negative 4. So I want everything under that line, but I can't stop there. It says it also wants x that's greater than negative 2. So here's my x coordinate, negative 2. I'm going to draw a line there. And if I want greater than, that means to the right. So that means I have to be under this orange line and to the right of this one. So anything that falls down here in this corner. Okay? And the points that fall there are M, C, K, and H. Okay? Again, if you want to, you can go and check the individual coordinates or you can draw the lines. It's your choice. All right, last one. Last one says which point has negative 3 less than or equal to x. So first let's look at our x and let's draw the line at negative 3. Okay. So the x has to be greater than that negative 3. So we're looking to the right of it. Or equal to. So can I include the n that's on that line? Yes, I can. But I also want an x that is less than 0. So here's where x is 0. Right there along the axis. Less than that. Can I include this line? No, because it doesn't say less than or equal to. So I need anything in between these two lines and up to this line. So the only one that fits that description is letter N. Okay. We will practice more with drawing the lines in this part. I'm hoping that at least, though, those first 3 you were able to complete okay. All right, now that we've done an overview of coordinate graphing, let's go ahead and move into our notes on translations. All right, so now that we have reviewed coordinate geometry and just the coordinate grid, let's get into today's lesson, which is translations. So first thing we need is the definition for translations. Okay, so a translation is a transformation in which a figure is slid, and I want you to see that SL there, slid horizontally, vertically, or both. Okay. So once again, a translation is a transformation in which a figure is slid horizontally, vertically, or both. And I underline that SL because if you notice, in the word translation, there are the letters SL. You can remember that SL means slide. So a translation is just sliding a figure. Okay. A translation is not, a translation is not a flip, an enlargement, or a reduction. So the figure, a translation, is only sliding. It is not flipping, it's not getting bigger, it's not getting smaller. It is the same figure, just sliding on the coordinate grid. So let's take a look at this example. It says number 7, but it's really our first example. It says record the vertices for triangle ABC in the table below. So let's start with just recording the vertices. So A is when you go right 2 up 5, so A is 2, 5. B is over 4 up 2, 4, 2. And then we've got C, which is 1, 1. Okay. Our next set of directions says to translate the figure 5 units to the left and 2 units down. Okay, and so this whole figure is going to slide. We've got to slide every single point 5 units to the left and 2 units down. So I'm going to start with A, and I'm just going to show you the jumps that I'm going to take with this figure. Okay, so here we go. A is going 1, 2, 3, 4, 5 to the left and 2 down. So here's my new point A. Okay. And we show that it's the new A by putting an A with an apostrophe after it. That means A prime. So this new point, A prime, is going to be at -3, +3. Okay. We're going to do the same thing for each one of the points of this figure. So we're going to take B, 5 units to the left and 2 units down. 1, 2, 3, 4, 5, and then 2 down. 1, 2. So here's my new point B, or B prime. Okay, and I'm going to record those coordinates. It's over to the left, -1, and then it doesn't go up or down. So that's -1, 0. Our last one, C, 5 units to the left, 1, 2, 3, 4, 5, and then 2 units down, 1, 2. And so our coordinates for point C prime over -4 and down 1, so -4, -1. Okay, and so if I now look at the new figure, I have the exact same figure, but the figure just, moved to the left 5 and down 2. So it's the same triangle. So let's look at what happened here. It says what happened to the x-coordinate. So the x-coordinate, here it was, when you look at it, the x-coordinate was -2, okay, or excuse me, +2, and it went to -3. 2 minus what gives you 3? -5, right? Because we moved 5 to the left. So it decreased by 5. Okay, let's look at the y-coordinates, and we'll look at a different one. The y-coordinate, so the y, remember, it goes x and then y. So our y-coordinate on point B was 2, and it went down to 0. So 2 minus what gives you 0, so it went down 2, if you look at our translation, 2 units down, or it decreased by 2. So the next question asks us, what is the rule that describes your translation? Okay, and the way we get that rule is looking at what happened to the x-coordinate and what happened to the y-coordinate. Well, the x-coordinate is decreased by 5, minus 5. The y-coordinate decreased by 2, minus 2. Okay, so the rule for this translation would be x minus 5, y minus 2. Because every single x-coordinate, we can subtract 5 and get our new coordinates here. Every y-coordinate, we can subtract 2 and get our new coordinates. All right, let's try another example. The next example says Pedro performed the following translation for his math homework, but he can't find the original problem. What translation did he perform? So what I want you to do is pause the video here while you take the time to go ahead and plot the two figures that are given to you here. All right, so hopefully you got your two figures drawn. You have your original figure and your translated figure. And make sure that that translated figure, you have the prime notation there, the apostrophe after it to let you know that it's the new figure. Okay. So the question asks us, what happened to the x-coordinate? Okay, so remember the x is the first one that you have here, and you can look at any one of them to see what happened. So your x-coordinate, if you're looking at point C, went from 3 to 10. So what happened? Did it increase or decrease? It increased. And how much did it increase? It increased by 7. Okay. There's kind of two ways that you can look at that. You can look at just the coordinates and see, what was added or what was taken away. Or if you want to, you could count on your grid how many spaces over that C goes. And if you count that up, it goes over 7 spaces. Okay. Our next question asks us, what happened to the y-coordinate? Well, let's look at one of the y's. Let's look at the first one up here. We had a 10, and it went down to 4. So this time we've got a y that is decreased, and from 10 to 4 it decreased by 6. Again, you can look at the actual coordinates if you want, or you can look at your grid picture and see how many times it goes down. 1, 2, 3, 4, 5, 6. Okay? So then when we're looking to describe the rule of what happened here, we're looking at what happened to the x value and what happened to the y value. So our x coordinate went to the right, which is the positive direction, or it increased by 7, so x plus 7. Our y coordinate, y went down, okay, which is negative direction, or decreased by 6, so y minus 6 is our rule for the translation. Okay. Notice again, same figure, it's just sliding. All right, we've got 2 more problems in your notes. The next one says point K, not point, but point K, -2, +7 is a transformation of point K, 0, -2. So that was hard for me to see. This is K prime over here. So the first one is K prime, and the second one's point K. Okay. What translation occurred? So we're going to look at the rule or what happened. Okay. So point K started out at 0, 2, and then it went to -2, +7. Okay. So again, we're looking at what happened to the x and what happened to the y. Okay. So let's start with that x value. Okay. So x was at 0. It went to -2. Okay, so did your x value go up or down? Okay, 0 down to -2, down. So it decreased, and by how much? Well, 0 down to -2, it's 2. It decreased by 2. And then we've got to look at our y value. Okay, So the y value was 2. It went up to 7. So it went up, meaning it increased from 2 to 7. Well, how much did that increase? From 2 to 7 increased by 5. So our rule here is that x was decreased by 2 and y was increased by 5. Another way that you can look at that is if x decreased by 2, well, it went in the negative direction, so this translation went left 2, and then the y increased. The increasing is going up the positive direction, so then it went up 5. So there's a couple of ways you can write that translation. All right, number 10, I want you all to pause the video while you try that one on your own. All right, I hope you tried number 10 on your own first. We're going to first look at what happened to the x value. So we're going to go with -7 and a +2. Hopefully you remember some rules about integers for finding the difference between -7 and 2. Okay. If you look at that on a number line, -7 all the way to 0, that's 7 spaces, and then 2 more spaces to get to 2, so that's a total of 9 spaces that the x value moved. And if we're going from -7 up to +2, we've increased by a total of 9. Okay. Next, we need to look at our y value. And if we take a y value, again, guys, pick what's easiest for you. I see a -4 and a 0. So to get from -4 to 0, I know that I have to go up, because -4 on the number line is like here. Well, I need to go from -4 up to 0, so I'm adding 4 to my y value. So our rule would be x plus 9 and y plus 4. And you can also think about what that would do on your grid. On a coordinate grid, if we're going plus 9, that means we're going to the right 9 if we were drawing the new figure. And then y is plus 4, it's going up, so we're going up 4 if we were drawing out that translation. All right, guys, hopefully you now have plenty of notes on translations. You have your homework attached to your notes, and I just want to make sure that I bring your attention to number 6. Okay, on number 6, make sure that you pay attention to the grid. Notice that it goes up by 2's and not by 1's. Okay, so when you're looking at the coordinates, let's say for point A, okay, point A, even though it looks like it's only over 2, when you're looking at the numbers, it's going up by 2, so it actually goes over -4 and then up to +6. So I'll go ahead and give you that first coordinate, -4, +6. Okay. All right. If you all have time left in class, you can go ahead and begin your homework. Make sure to have these problems completed when you come to class tomorrow. Have a great day.